Okay, let's talk a little bit about some properties of matter. Let's talk about some ways we can kind of categorize different properties of matter first. So one common way that we classify different properties of matter is by way of what we would call quantitative or qualitative. Okay, and so hopefully that's just what it sounds like. So quantitative properties are things that relate to a quantity, so a number. So properties such as mass, volume, density, temperature, those are all properties of substances. And those properties we typically actually give a quantity. So if we want to talk about the mass of a substance, we give you a numeric value, okay, or the volume or the density or the temperature. Those are all associated with some numeric value. So they're classified as quantitative properties, okay. You can also have properties of matter that we call qualitative. Okay? And so that is describing some sort of quality, okay, of that matter. So things like color. Usually we wouldn't designate a number for color, although you could. It's just describing it when we're talking about color. It's not a measurement, it's not a number. Or the shape of something, or its texture, or even its physical state. All of those are describing important things about a substance, but not in a numeric way, okay? So in chemistry, it's very important to discuss the properties or to observe the properties of things to help understand them. And both quantitative properties and qualitative are both very important. They tell us a lot of stuff about our substances that we're studying. Now, that's one way we can kind of break down, I guess you could say, observations about something. We can classify those observations of your matter as quantitative or as qualitative. That's one way to look at it. Now, another way that's very common that we can talk about different properties of matter is whether or not they are physical properties or chemical. Okay, so a physical property, that's something that you can observe or you can measure without changing what you have. Okay, so things like mass and temperature. Well, I can go measure the mass of a substance and it's still the same substance. Just me going and putting it on a balance doesn't change it. Okay, or I can measure the temperature. I can put a thermometer in there and it doesn't change the substance. It's still the same compound or mixture of stuff, whatever. The color as well, you're just looking at it, so you're not changing what it is just by looking at it, or the odor, you're smelling it, or the physical state, again, you're just looking at it. Or things like melting point, boiling point, those, it can be a little tricky. A lot of times people will think that you are changing it. Well, you're not changing chemically what you have if you measure a melting point or if you measure a boiling point. In order to measure those things, you change the physical state of the substance. Okay, so you're transitioning it either from a solid to a liquid or other way around, or a liquid to a gas when you measure these temperatures, but it's still the same substance. Okay, so if you boil water, it starts as a liquid and it goes to the gas phase, but it's still water. Okay, it's still H2O molecules. So you're not chemically changing it, you're just physically changing it in that case, okay, which you can do to observe a physical property. Okay, and so like in the pictures I've got there, we can make different physical observations just by looking at those pictures. You could say, well, in that first picture, I've got a pink solution, a purple solution, and a blue solution. Okay, and I didn't change. Just because I said the first one's pink doesn't make it suddenly change into a different substance. It's still the same substance. In that second picture, you can say, well, I've got a yellow solid and then a yellowish looking liquid above it. Or I have an orange solid and an orangish looking liquid above it, or clear liquid above those things. It could be that they look yellowish and orangish due to the lighting reflecting the color off the solid. Okay, but just by me making those observations doesn't change what the substance is. Or if I actually had those physically and went and put it on a balance and measured the mass, or put a thermometer in there and measured the temperature, it would still be the same substance. So those things that we can observe or measure without changing chemically what we have, those are physical properties. Whereas we could also have chemical properties, and those are things that you can only observe by changing what you have. Okay, so you have some starting substance. In order to understand a chemical property or actually determine if it has that chemical property, you have to do some sort of chemical reaction. Okay, and so I give a list of some different types of chemical properties. So reactivity, that's a very generic, general one. Okay, reactivity with what? Well, it can react with lots of things, right? But if we're talking about reactivity, we would focus on, is it reactive with this or that? You know, and the only way you know is to put it with that substance. And if it reacts, now you don't have what you started with anymore. Okay, so the only way you can determine that is by changing the substance or by trying to. Or the only way you can determine if something's flammable is if you try to light it, right? And so in that first picture, I've got a little flask and something's burning there, right? And so definitely whatever was in that flask is flammable. But now that it's burned, it's something different, okay? Or in that second picture, we have all these different, wells with different colored solutions in there. Well, those actually started all as something specific, one specific thing, a clear solution, and then we added different things and we got all these different colored solutions. Some of them have solids in them, and so those are now changed to something different, and it indicates that yes, that substance that I had is reactive in this substance or with this substance I add. Okay, and so the only way you can determine it is by changing that. Okay, also things like toxicity of substances, heat of combustion, electronegativities, acidities, all of this stuff, the way we measure them is by doing chemical reactions, okay? Or the way we observe, is this, that, is it reactive or not, is by trying to react, okay? So that's just another way we can kind of look at things. And so right now I want to focus on some physical properties, because usually when you get started with chemistry, that's what you focus on, is first the physical properties of things and trying to observe those. And then you get into the more complicated chemical properties, so actually doing chemical reactions. So let's talk about some very common, just basic physical properties that we can first measure, and then we'll look at kind of some important observables. So measuring usually indicates we're taking some numeric value. Okay, so we're using some device to get a measurement. And so one is mass. That one's very common. It was very rare that you would do a chemistry experiment and not measure a mass. Okay, most of the time you're measuring masses. That's very common. So that is quantifying for us how much matter that we have in this object or this sample that we measured the mass of. Now, units for mass, there's lots of different units. Usually everything in chemistry, it's some sort of gram base unit. So you can have the SI system, kilograms. The metric system is the grams with the different prefixes, or you can talk about English system if you want, pounds and ounces, things like that. Okay. But the key is you're going to have some numeric value, some unit with it, depending on kind of what scale you use to measure it. Okay? But it's telling us how much matter we have. okay? And by measuring that, we don't change what we have. Another really common one that we use in chemistry a lot is volume, okay? And that is measuring how much space something takes up, okay? And there's lots of different units we can use for this. SI unit is meters cubed, so that's a little more unusual unit for us to use in chemistry, but you can use that. The metric system is technically based off of cubic distances for volumes, so meters cubed, centimeters cubed, things like that. But the most common that we would use in chemistry are things like liters or milliliters, and those are just derived from these cubic distance units. And then you have English units, what most people are a little more familiar with for measuring volumes, gallons, pints, quarts, things like that. Now, another really common physical property for us to measure in chemistry is temperature. And if you just want to think about it in a very basic way, it's telling you how hot or cold something is relative to a standard, okay? And the standard is based on units of either Kelvin, Celsius, or Fahrenheit. Those systems really, well, the Celsius and Kelvin are really based off of water's melting and boiling points, whereas Fahrenheit is more related to body temperature. But you can tie it, you can relate it to water's boiling and melting point. It just seems like it's an odd scale then. Now I do have on here the conversion equations to convert between Celsius temperatures and Fahrenheit. In chemistry, that's not generally all that useful because we usually don't measure things in Fahrenheit, but we do measure things in Celsius a lot. And when we have to do calculations with temperatures, most of the time they need to be in Kelvin. So that second equation is typically very useful. If you have a Celsius temperature, you just add 273.15 to it, and it is the Kelvin temperature then. Okay, so those are some really common physical properties we measure. Now, that's not the only physical properties that we measure so that we get numeric values, but those are the most common in chemistry, at least when you're getting started. Now, another really common physical property that is important to understand are the states of matter, okay? And so that's a common observation. When you're doing experiments, you should note, is this a liquid, a solid, or a gas, or was there a transition between any of these phases or physical states, okay? And not only that, you should understand kind of what distinguishes these different physical states, okay? And I mean, that's part of the observations as well. So solids, hopefully you already know, are things that have some sort of fixed shape, a fixed volume. The volume doesn't change with pressure, so you can't squish it and make it smaller. And the particles are really fixed in place. And usually they have some regular arrangement. So if you really had a solid sample and you zoomed into it and looked at what it looks like microscopically, you would have these different atoms or molecules arranged in this nice regular pattern, or typically, it doesn't have to be, but even if it's not a regular pattern, those things are kind of fixed in place. They're interacting with what's around them and they stay put, okay? Now, of course, you could take a solid and you could break it up. You could grind it down into a powder and then it seems to move, and change shape. But that's not what we're talking about. We actually have a solid sample, okay? Not breaking it into tiny, tiny pieces, because then you would have to talk about those tiny pieces as one thing, okay? As different solid samples. Now then we can also have liquids. Liquids, hopefully you already know, are things that take the shape of their container. They're going to have a fixed volume, okay? So with a liquid, it can shift and reaccommodate a container, but if you actually have a solid and you put it in some container and then put it in a different container, it still has the same shape. If it's a block, it's just a block. That's what it is. Or if it has these jagged edges, it doesn't matter if you put it in a different container, it still has those jagged edges. But a liquid, it's going to flow and shape to that container, okay? But it does still have a fixed volume. So even though that volume can spread out differently, it's going to have that same volume no matter what container you put it in. Although if you really compressed a liquid, like if you really pressed on it hard, you could get it to slightly change, okay? But typically we would say the volume does not change. Now with a liquid, the particles are definitely randomly arranged. And they also are moving constantly, okay? So they're not stuck next to the same neighbors all the time. They can move past one another and move towards something else, okay? Whereas then gases then have the most freedom of all of these things. Gases are going to take the shape of whatever container you put them in, okay? And the volume is going to depend on that container. So it's always going to spread out and fill up that space, okay? And so you can put this gas sample into a larger container and it's going to spread out, or you can put it in a smaller container and it's going to, compress together. So with that, the volume of a gas sample can be changed. You can compress it and cause it to take up less space, or you can let up on the pressure and cause it to expand. And in a gas sample, the reason that that's possible, that you can compress or things spread out, is because the particles are always going to be separated from one another. You don't, if you zoomed into a gas sample, you don't have all these particles touching each other. There's always a bunch of empty space in between them, okay? So there's room to compress it because there's lots of empty space, but there's also, if you expand it, they'll just spread out more and have more empty space between them. That's just naturally how a gas behaves. Okay, so you should be familiar with general characteristics of solids, liquids, and gases and understand how there's differences in their volumes, how they behave when you put them in different containers, things like that. So those are just some important physical properties of substances. So we're not going to go into, different specific chemical properties. At least I'm not going to in this video. That you get more into when you go into actual chemical reactions.